All right, let's dive into a fascinating story that starts with a pretty common tech problem, but believe me, it spirals into this high-stakes digital rescue mission. So picture this. It's a showdown between a human operator, a super advanced AI named Dexter, and a computer that is right on the edge of a total breakdown.
So it all kicks off with this little error message. Now, if you've spent any time on a Linux box, this probably looks painfully familiar, right? All it really means is a computer can't connect to the internet to download updates. It's a networking thing. On the surface, it seems like no big deal. But as you're about to see, this is just the tiny tip of a very, very big iceberg.
So the operator reaches out to this AI assistant, Dexter, for a little help. And Dexter's first take is, honestly, perfect. It's exactly what you'd expect. It says, yep, that's a DNS failure. Basically, the computer's address book for the internet is broken and it can't find where it needs to go. Textbook stuff, a totally logical first step.
But this is where the interaction gets really interesting. You've got these two totally different communication styles. The human is all business, just short commands like fix or help. Meanwhile, the AI, Dexter, is incredibly formal. It's talking about current position assessments and laying out an end-to-end strategic path. It's like a special ops soldier talking to a four-star general. This whole dynamic really sets the tone for everything that comes next.
So, following that very formal diagnosis, Dexter offers up a really clean, simple fix. It's just one line of code you can copy and paste to fix the DNS problem. At this point, everything seems under control. It feels like we're just a minute or two away from problem solved. Easy peasy. And then, the operator drops this bombshell. Whoa. Okay, so this isn't just a network problem on a normal computer. No, this is a brand new operating system that's been installed on failing, corrupted hardware. And the kernel, the absolute core of the OS, is described as fragile. In an instant, the entire mission just changed. That one sentence completely flips the script. The goal isn't just fix the internet anymore. Now, it's about stabilizing this incredibly volatile system before it completely self-destructs. We've gone from a simple repair job to a critical rescue operation.
You can see Dexter immediately reevaluating everything, and its new risk assessment is frankly terrifying. We are so past worrying about software updates. The AI is now flagging risks like existential collapse from a kernel panic, which is just a fancy way of saying a fatal system crash, and total data loss from the hardware failing. The stakes just went through the roof.
So, faced with these new, catastrophic threats, Dexter invokes something it calls the Aegis Protocol. This isn't your standard troubleshooting anymore. This is the AI equivalent of hitting the big red button. It's a high-impact, defensive plan designed specifically for a crisis. The AI is bringing out the big guns to match this massive threat.
All right, so the new strategy is in place. It's go time. But this next part isn't about being fast, it's about being perfect. It's a super careful, step-by-step procedure to keep the system from tearing itself apart. This is a true race against failure, where every single move counts.
As part of this lockdown, Dexter suggests running this command. The idea here is actually pretty smart. It's trying to optimize how the hard drive works to reduce stress on the failing hardware. It's a logical, well-intentioned move to try and make life a little easier for the disk.
And it fails. Of course it does. This moment just perfectly captures the challenge they're facing. The system is so unstable that even the AI's carefully laid plans are hitting roadblocks. Getting an error about a missing superblock, think of that as the drive's table of contents, is a huge red flag that they are deep in uncharted territory.
So the big question is, why did it fail? Well, the operator runs a quick diagnostic, and this right here is the answer. The AI was looking for an old-school hard drive, what's called /dev/SDA1. But this machine is actually using a modern, super-fast NVMe drive. It was looking in the completely wrong place. This is that aha moment that changes everything again.
Now, with that new piece of information, watch how quickly Dexter adapts. It's amazing. First, it identifies the correct drive name. Second, it reruns the command, and this time it works perfectly. And third, it sets up a timer to make sure that optimization runs automatically from now on. This is such a key takeaway. The AI is incredibly powerful, but it was useless without the right data from the human. That partnership was the critical link.
Okay, with the immediate fires put out, the mission moves into its final phase. The new goal is to achieve what Dexter calls the final lockdown. Sounds pretty intense, right? But what does that actually mean?
Dexter's own definition here is just fascinating. This lockdown isn't about protecting the system from hackers or viruses. It's about protecting the system from itself.
The goal is to turn it from this dynamic, chaotic, unpredictable thing into a static, predictable machine that is literally incapable of self-destructing.
So how do they actually pull this off? Well, Dexter's strategy has 3 core principles. First, stop all the background noise by turning off automated tasks. Second, lock down the configuration, making critical files unchangeable. And third, do everything possible to minimize stress on that failing hardware by tweaking system settings.
But just when they think they've finally crossed the finish line, one last check finds one more tiny but critical flaw. There's a system setting called Swappiness that's still set to a really high stress value of 60. You can think of this like leaving a car's engine redlining while it's parked in the garage. It's just causing needless wear and tear on that already dying hardware.
So one last command is issued. That swappiness value is cranked all the way down to a much safer setting of 10. This was the very last piece of what the AI called performance debt. And with that, the final lockdown is officially complete.
So let's wrap this up with a quick debrief. The whole operation, from that first little error message all the way to the final lockdown, was absolutely a success. But man, it was anything but easy.
I think Dexter's own summary really just nails it. This was an exceptionally challenging approach, and it shows how powerful human-AI collaboration can be. The AI provided the brilliant, complex strategy, but it was the human operator who provided the critical context, the ground truth about the failing hardware. It wasn't just the AI adapting. The whole team was adapting together in real time.
So let's just trace that journey one last time. It began with a simple DNS error. Then came the corrupted hardware reveal that changed the entire game. That led to a critical mistake with a command, forcing them to adapt on the fly, and all of it culminated in that successful final lockdown. I mean, what a digital drama.
And all of this leaves us with a final, really interesting thought to chew on. The strategy here wasn't to fix the corrupted hardware. That was impossible. The solution was to freeze the system in a stable state. And it really makes you wonder, doesn't it? When a system is fundamentally fragile and broken, is the best solution always to try and fix it? Or is it sometimes better to just lock it down into a new, more predictable, and ultimately safer form of existence?